Okay, and I think we are live. Excellent. Good afternoon out there in YouTube or Facebook land or wherever you happen to be streaming this from. My name is Brian Jata, Sales Director at Trotec Laser UK, and I have with me Alex Beckingham, who's our Applications Manager. And today we're going to have a focus on productivity. Now, we talk about our machines being the most productive that are out in the marketplace, but this is not about machinery. This is more about general setup, the best ways to configure your artworks, how to rotate your plates, things like that, how to get the best out of whatever machine it is you have. So it's non-Trotec specific. This is hints and tips on how to get maximum productivity out of what you've got. Of course, we'll be using our machines for the live examples, but the techniques work for both. So a little bit of housekeeping. You'll see that you've got the chat feature on the right-hand side. If you've got any questions, please drop us a line and we will endeavour to answer them. And then if there's anything we don't get to answer, we'll do a bit of a Q&A at the end of the stream. So, Alex, what have you got for us today?
Well, we're going to be really focusing today's session on looking at labeling and data plates. So this is a predominantly heavy engraving process. And what we're really going to be doing is take you from really the worst case scenario in terms of setup. It's a little bit unrealistic, the worst case scenario, but really the idea is to show you the step-by-step process to go from something where we're not very productive, we're not making the best use of the machine, to then something where we really are taking advantage of all of the actual capabilities itself. And again, if there are other kind of topics other than engraving that you would like to see a webinar on, then please do leave comments in the chat and things like that, and obviously that will give us ideas for future sessions. So let's get into it and have a look at the worst case scenario. So the worst case scenario tends to be when you're producing a one-off item. So you're just loading an object into a bed to work with. It's when you've set it up so that the engraving height is larger than the width, and it's just when you're using your run-of-the-mill standard setting to actually produce the result. So this is the file that we're going to be looking at. So it's a data label, and as you can see at the moment, we currently have it set up so it's taller than it is actually wider. So we're just going to quickly run you through the process of getting a job into the machine as well, just for anyone who doesn't have a Trotec, just to see kind of the workflow that we're working with. So we're going to take the file, and so we're just going to go to File and Print. And then here in our setup and our settings, we then choose our setting that we want. And then we're going to print that through. And then we're going to come across to our job control software. So this is the interface between the laser and the process to get the job across. So over here we have all of the jobs, and as you can see in the list here, we have the job that I've just sent across. So nice and easy to get the artwork across. I'm now going to switch across so you can see inside of the machine. So I'll quickly give you a little overview of the actual setup process as well. And I'll just make this a little bit bigger so you can see. So you're looking inside of a Speedy 300, and I'm just going to use the keypad to move the laser head across to where I want the laser job to start. So I want this to be the top corner. I'll just move the camera a little bit so you can see. And once I've set it so that the laser head is in the position I want it to be, then we can come back across, and over here we can now see that this crosshair is where the laser head is, and I can take my job and I can snap it to the start. Of course, shut the lid so that the job will run, and then we can start the job off itself. So I'll just give you a couple of seconds just so you can see the machine running, and then we'll carry on with the presentation itself. So a few things to note here. Obviously, this is where the engraving is taller than it is wider. And another thing you may see is that we've actually started at the bottom of the job. So the material we're working with today is a Trolec, and it's a 2-ply laminate designed for engraving. And by having it so it engraves from the bottom to the top, you're just really minimizing the amount of cleaning that you need to do and allowing you to get a nice result straight from the machine.
So I think it's whilst that is the worst case scenario setup, Alex, it is something that we do see people do when they're trying to maximize yield out of material, for instance, don't we? And yes, it's good to maximize the yield, but you've got to understand that that will have a negative effect on how long it takes to run the job.
Yeah, I mean, I've done it plenty of times myself as well before, where somebody gives you a bit of artwork, they've set it up, so it looks right to them in the drawing, you send it across to the machine, and before you know it, you started running it, and you could have processed that job a lot faster with just a couple of little steps in between.
Yeah, for sure.
So, the run time for this, obviously I've already timed it, so we don't have to sit here, but it's 144 seconds, so it may not sound like a lot of time, but of course everything we're doing obviously is based around the Trotec speed, and of course all of these tips will be amplified if obviously you're working with a slower type system.
So the challenge to Alex was to get this job running 5 times quicker than the first attempt. I think that was right, Alex, wasn't it?
Yeah, it was around 5 to 4, depending on how much pressure there was. So let's just discuss a little bit about why this is the worst setup with the actual machine itself. So you can see here that at the moment we're not taking advantage of the actual full high speed part of the arm. So the red dot or the red square on the drawing here is the laser head, and as the laser head moves left to right, it moves at a very high motion speed. Whereas when we have the actual front to back movement, so your y-axis, that's all based on the actual resolution, and that's the slow movement. So it makes fairly simple sense that obviously by having as much of your job for the engraving along the higher speed part of the machine, then you can actually get much better productivity. So essentially, very simple tip, but always make the engraving as wide as possible. So
just to clarify that, Alex, for people that might be used to different terminology, we're calling it resolution. That would be your number of dots per inch with a mainstream machine, or scan gap, I think it's called on a lot of the glass tube machines.
Exactly, yeah. So those are the two kind of base names that we come across. So what we're going to do quickly now is just show you just how quickly it is to improve the job. So obviously that took 144 seconds. And we can simply come into here, rotate the job so that the job is now wider. And then I can just position the laser head across. Again, take the job to the laser head, and then we can start running again. And so now we're going to be able to take more advantage of the high speed on the actual motion system itself. So again here, by having that job slightly wider, we're then able to run it that much faster.
And so for this second version, what's your time saving?
So because we are roughly, I'd say we're probably just over half as tall as before, and we're able to, start to use more of the speed, I'd say it's going to be pretty close to that on this kind of job file. So we're going to be about twice as quick, or very roughly thereabouts.
Okay.
So if we have a look, and I will just bring back up the presentation again. So for this job, we're taking advantage of the high speed. And another thing to note is sometimes when you are engraving at very high speed, it can be a little bit difficult for the laser to pick up fine lines. So just a little tip is that you can obviously adjust this, and I do this quite frequently. So if you do have a fine line on the job, you've got several different options. You can either score the line, so change it to like a cut process and just have the laser follow the actual lines. You can just increase the line weight, which again is a very quick and easy way to do it. Or for example, if you notice it tends to be just a vertical line, so where the laser doesn't have much time to fire, again you can just slightly increase the line weight there as well. So we can now see we've gone from 144 seconds down to 86 seconds. So already we've got a very significant time saving just by rotating that file itself. And just to show you the actual results that we are getting from the machine as well. So you can see from the machine, we've got a nice label here. See if I can get it to focus, probably can't. There we
go. No, you're good.
And as you can see, I've not cleaned that at all. I've literally just picked that up off the bed. And part of that is just making sure you have just the right setting. So not too much power on the engraving, and then also having that engraving direction set to bottom up.
Okay, so far you've got to nearly half the speed of the first one, nearly. So what are you going to show us next to make it quicker?
So the real thing we can do to really take advantage and improve the result is to really start to understand how the acceleration and how using all of the bed affects our work. So that's, rather than doing one off, we're now going to start to use more of the laser bed and start to create multiples. So with our current job, yes, we have made it wider, but it's still quite a narrow engraving. And when the laser obviously is going from left to right, part of that process of going to left to right is an acceleration. So it's speeding up as it comes across, and then as it gets to the other edge, it has to slow down. So if you have a very narrow graphic, what you find is actually the laser head is always speeding up, and then it's always having to then slow down again. So you're never actually allowing the laser to get up to its maximum speed. And again, all of this is a lot more noticeable if you have a slower accelerating machine. So of course, even with our speedy 100, 300 now, we have 5G of acceleration. But if you're looking at an entry level machine, which is maybe 1 to 2G of acceleration, this is going to be even more noticeable. So what we want is more like a setup on the right hand side here. So the laser head is able to accelerate. It's then able to reach that target speed, so the speed you've set in the setting, and then it slows down. So it's actually allowing the laser to make use of its actual maximum speed. And it can be something that quite a few people overlook. So a way that people commonly encounter this is you'll use something very narrow to determine your engraving setting, but then you're only engraving in this acceleration zone. Then you take the same setting, use it for the full bed, and sometimes you'll get a slightly different result. And that's because you've not allowed the machine to actually get fully up to its set speed.
And we tend to see that more with the glass tube machines than we do with the higher end systems, Alex, don't we?
Yeah, I mean, with obviously the Speedy series, it accelerates so fast you don't really see it as much, but definitely on the entry level machines, you can really start to notice it. So let's take advantage of the high speed of the system, and let's see how that affects the productivity of the job. So what we're going to do is we're going to take the label, and we're now going to complete multiples in order to really see how that affects the job. So just quickly run you through this. So this is just a typical process. Of course, you can do this in any type of software. So you take your single label. Of course, we want to make sure it's wider than it's taller. And then with that label, we can then come across and we can start to populate it to make use of the material. But the thing to note, especially with a job like this, is especially if you're doing something that's like a data plate, is we then need to also come into here and start to adjust our data as well. So of course, it's great if you're doing something that's exactly the same, but say you offer a personalization service, or each of your products is bespoke in some way, then of course you're going to have to come across and you're going to have to start to edit the data and so on. So once you've undertaken that process, again, we're using the print process. So we go to File and Print. And again, we come into here, but I'm not going to change anything. So we're going to use exactly the same setting as before. And there we come across. And we don't need this job anymore. So again, if you wanted to use this again, we can put it back into the queue, or you can obviously delete it. And now I can bring on the new job. So you can now see we have all of these labels set up like so. And again, I'll bring the laser head across, set it up, snap the job to where I want the job to start, and then we can just click the start on here. And again, just so that you can see a little bit of the difference, you can see that that head is now really moving at a high speed. So we're now allowing the laser to reach that maximum speed and really start to make use of the performance of the system.
Good. So where's that going to take us time-wise then, Alex? Because we're all looking at how fast is he going to get it to? Where's he going to get to?
So this is pretty much the biggest step that we're going to see during this process. There's still many gains to be had, but again, obviously we've run this so we don't have to sit and watch each of these labels, but we're now down to just 23 seconds per label. So an absolutely massive time saving in terms of your production. And of course, we now need to consider the next step, which is also the actual setup of the actual drawing itself. So as you can see, we're only editing one data field per label, but that still takes quite a bit of time if you're manually doing that process. So the more you start to do, or the more volume of a product, you actually then need to spend a lot of time doing your job setup, and that's when you then really need to start to consider the actual impact that the job setup has on your total production time. So what I'm now going to do is run you through a little bit about a workflow optimization, and this will hopefully give you a better idea of how you can do this. So I'm going to use a bit of software called EngraveLab, but this is available in many different software packages, and this will of course be available with our next generation Ruby software as it's continually developed. So a lot of this is going to be very applicable to a lot of our customers.
And again, if there's any questions, please pop them in the chat. Happy to answer any questions as we go or at the end. So please ask away.
So I'll just make this full screen so you can see a bit easier when we do this run through. So the big difference you'll now notice is the fact that with the drawing, rather than have the data in here, I now have descriptions for that data. And also for this drawing, I actually used the graphic software that I'm more comfortable using, so CorelDRAW. Obviously, a lot of our customers use things like Illustrator, and then I've imported it into here, so you don't have to do all of your drawing work in here. So I'm just going to add this field back in so you can see some of the advantages. So generally, I'll make sure that we are using the same font so it all matches up. You can then position the artwork, and then we want to just come into here and change it, but now just make it a description. And then the next thing that's really quite interesting is the fact that we also have then some more abilities. So now what I can do is with this, I can actually change it so that we can change the actual compression method. So this box now represents the actual fillable area. And what you'll notice is as we add more and more text, it actually just resizes it. So you can either have it adjust via size or compression, but the main takeaway is it doesn't matter what kind of data the customer gives you, or if you're putting in different names, say you're personalizing an object, it's still always going to appear in the graphic in the right place where you actually want it to be, which obviously can otherwise be a bit of an issue if you have to manually resize and adjust it all. So from that point, I've now actually set it up so we're going to be importing 3 different lines of data. And in here, I'll just give you a quick overview, of course. If you do want more detailed information on this, we can obviously arrange something later, so please do get in contact with us. But here, to give you a rough idea, we set our size of the material that we're working with. We can then set how much of a gap we want to the edge of that material. So I tend to make it at least the material thickness just to avoid any warping. And then we can also choose the spacing as well. So this is the setup of our material. Over here you can see it's automatically picked up all of the data fields, and we want to modify these 3 data fields here. We can then find the document to bring in the data. So in this case I've got a file that I've generated from Excel, and then here you can see it's automatically brought in the data. So what you can do is you can of course rearrange this, so you can actually change each of these columns and move them about if you wish to. And here you can also delete any of the data that you don't want. So in that case I just added some headings, which of course we don't need for this. And just like that, we now have all of the labels set up and we've actually adjusted each of the data fields. So you can see it's all adjusted here. And the great thing is, with this process, it doesn't matter whether you're doing 1, 2, or 500. It's a very quick and easy process. And once you've got this template set up, you've already got your file, so you just select. Going from start to finish really doesn't take any time at all. And if you filled up all of your materials, so say these went all the way across, then all it will do is it will continue to add pages along the bottom here. And that way you can just go from each sheet and just keep producing the labels up until the point you're ready.
I think it's important to add, Alex, that of course your customers got to get this data to you in some way. So chances are they've already got it as an Excel spreadsheet. So there shouldn't be too much manipulation required by yourself to actually take that data and make it very easily importable, at which point any spelling mistakes or typos remain the customer's issue and not your fault as well.
Yeah, and I think that's really something that, especially when you're going through all these numbers and adjusting things like that, it's just one little typo. And then especially if you're, say, marking something produced by a customer, then suddenly you've got to explain to the customer that you need another part, and the one that you've marked is obviously isn't fit for a purpose. So approximately to do these 9 labels, so kind of the start to finish process takes about 22 seconds. I just did a rough calculation, but that is for however many files are in that Excel spreadsheet, so it's automatically just going to keep adding them. And so of course you'll get even more savings as you start to have more and more complex artwork, or if you're starting to produce more and more items. So we'll just quickly come across, and we're now going to move on to the next part, which is having a quick look at the actual resolution. So at the moment, we have been doing everything at the standard resolution. So this is the lines per inch or the dots per inch, depending on what you're used to working with. And by standard, it's 500. But what you can find is that it's very actually easy to get still a very good result and a significant time saving by adjusting this factor. So going from 500 lines per inch to 250, the job would be twice as fast. But it's worth bearing in mind you may have to make some small adjustments, so there will be some slight loss of quality. So all I've done is to take the standard file, and actually what I did was I made the file bold, and it just gives the laser a little bit more time to fire and still results in a very legible result from the machine. And by changing from the setting which I had previously, so at the 500 down to the 333 setting, we're now all the way down to 16 seconds per label. So roughly about just under a 30% saving.
And a huge saving from 144 seconds where you started from.
Exactly, yeah. So you can see just how taking all the time of each of these little steps really starts to result in some very big gains. And here is an image of the test that I completed, and you can see over here I've made the text bold, but it just means it gives the laser a little bit more time to fire, and means that even with a lower resolution you can still get a very legible result and something that's fit for purpose.
And in some applications you might find that 250 is absolutely fine, at which point you're going to make even further savings, especially with large text. We tend to see with large areas of engraving that low resolution or high resolution, you can't really tell the difference.
Yeah, exactly. And especially, like you say, when you start to do anything that's, say, wall mounted or anything else like that, you're not looking at that object very close up, so you can really make some savings. So as a summary, we started with the worst case scenario over 140 seconds, and we're now into the 16-second range. And so we've gone from a single off item that's taller than it is wider. And then obviously we've rotated it so the object is now wider. And then of course you can see then this big saving that we can make by starting to look at batch production. And again, I know obviously we've been looking at data labels, but if you're even, say, personalizing objects, rather than just putting one in the bed, you can obviously start to make use of the area and start to put multiples in. And then again, by doing some fine tweaking with the settings, we've then able to make even more of a saving. So just over 5 times faster, So hopefully keeping Brian happy today.
Yeah, just about. Well done. Good job.
And what we'll do now is, again, you can see a little summary here of the text, but we're now going to look at the final part of this, which is actually the loading and unloading and actually the setup of the jobs themselves. So anyone who has produced lots of items and lots of cut components has probably at some point experienced something like this on the left-hand side, where you've got all of these items just laying in a bed. It can be difficult to move them in and out, and quite often they can get scratched and damaged. So I'm just going to take you through a quick example of, instead of cutting them all the way through, we're just going to have the setting slightly too fast to cut through it. So again, we're creating a time saving, but it means the part is going to stay in the actual material. That means you can just load and unload the sheet complete rather than having to pick up all of these little bits.
And let's not forget with the cut through as well, whilst the labels can get scratched and damaged, so can the operator. I think anybody that's used a honeycomb table for any serious amount of time will have cut themselves on it at some point.
Yeah, and it's just, there's so much, it's also reducing the cleaning and everything else. It's just a good thing to do. So we're just going to take the file, and I've just set up a setting here. So it's just going to run it quite a bit faster. And then we'll snap it to the laser head like so. And this time I'm just going to cut it so that you can see just the actual cutting process. And so we'll just quickly run this job. And we'll move the laser head out of the way. So what we're going to find is that by using just the kiss cut function, we're able to make it so that the part is still in there, but you can see it's very near to being cut through. It means it's very easy just to take that and to very easily just clip it out and unload it. So it's a quick and easy tip to apply, and it especially works nicely with things like tray lasers. Of course, if you're working with material like wood, of course that can start to actually fracture and tear, so you do need to be using the right sort of material. But we do also have the links function in our software where it can partially cut at intervals as well, so just makes the unloading loading that much easier.
Absolutely, and also cleaning as well. So it's much easier to clean a whole sheet if it requires any cleaning down than it is to clean individual badges or labels or whatever. So it works well in multiple applications.
So for the final little thing we're going to look at is we're also now going to look at using jigs. So jigs are very useful. There's also several factors that some people also don't really realize. So by having a jig which is cut to fit the component, it also acts as a form of quality control as well. So if the part doesn't fit into the jig, then you know something's wrong with actually the parts that you're being supplied, and can allow you to identify that earlier. And again, if you imagine if one of these little data tags was, say, too big, and you're just putting them up in the bed and just putting them to the corner, that if one of them is too big, it's then going to start to knock out all of the ones that you've stacked next to each other after that. So it can really help to reduce wasted material as well. So we're going to just do a little bit of a live demonstration. I'll just quickly run you through using one of these jigs. So I'll just take this jig here. So we're just going to take the jig, and you can see all of the little plates are loaded into here. We've just got some little cutouts which are make it a little bit easier to load and unload, and I'm just going to put that to the top corner over here. And then we can come into job control. And then we can bring on the file itself. So here you can see, as we've made the jig on the laser, it means we've already got the exact template and the layout for that design. And it means all I do is I take those red lines that we're using for cutting, turn them to a different color for positioning, and then you can start to add your text. So in this case, we're just going to add some Trotec logos to the center of these. And then away it's going to go. I've almost clicked the right button there.
So of course these are metal plates that you're using here, Alex. So stuff that we couldn't have engraved and cut on the machine itself, because that's always going to be the most accurate way. But for pre-manufactured items, this is why you would use a jig, yeah?
Yeah, exactly. So anything that's pre-manufactured, like I say, if you can cut it out on the laser, then you might as well do it as a single process. But doing it this way just makes it that much easier to load and unload. And of course, you'd have multiple jigs, so that means your operator can load and unload one while the other one is actually processing in the machine itself. So the final step to this is the fact that you can also add an extra part to this design, and you can actually aid your unloading. So what I've made is another half to the jig, and I've put some little cutouts in the bottom of the jig here, and then that way when we actually load the jig, so the jig with the parts, it means it can be very easy to actually unload the bits that you've already processed. So again, I'll just quickly make this a little bit easier for you to see. And you can see we can take this, and this is the other half of the jig, and then we can just simply put it onto there. And what that's going to do is it's just going to raise it up, so it means that I can very easily just flip up and take the parts out. So very easy to unload and load. And again, if you wanted to, you can make it so it actually sits it above the jig, and then that way you can just brush the ball off or slide the ball out into your dispatch location.
So simple design, but what a time saving that is. Just in lifting and loading and unloading, isn't it? Phenomenal.
Yeah. I'm sure, as we've all experienced, there's always especially if you've got a part that's a bit tight on the jig, then it ends up jammed in there, and it's a pain. And so it's a real frustration saver as well as a time saver.
Absolutely. So that's us, isn't it? We're done. I think we're on time as well.
It's a miracle.
Anybody got any questions? Pop them in the chat, please. In the meantime, follow us on Facebook, YouTube, Twitter. Got to remember what all of these are. Instagram, LinkedIn, Pinterest. Follow us on all of these things. Subscribe to our YouTube channel, where you'll find lots and lots of other content. But if nobody's got any questions, then we will disappear. We'll give it 30 seconds. And if no more questions come up, then we will close the broadcast and thank everybody for watching.
And again, if you do have any ideas of any other topics you'd like to see covered, then do use the inquiries email address and let us know what you'd like to see.
Absolutely. Yeah, we're always looking out for what we can bring you, what people actually want to see, rather than necessarily what we want to do. Not always the same things. Okay, well, there's no questions coming up, so we will end the broadcast. Thanks, Alex. Appreciate your efforts today. Top stuff. And we will be back live again next month. Thank you very much.
Thanks, everyone.